going to get on this set of questions, but it's a good one. We've got shows a current through a 3.5 ohm resistor as a function of time. And so at first there's no current, as we can see, and then we have 2.5 current. And this, it's hard to see, but this is 1.25 amps. Okay, and this is 2.5 amps. But we've got it over a period of time. So when we're seeing the question, how much charge flowed through this, the equation I'm going to use is that current, I'm not sure if I got it on this equation sheet, here it is. Current is equal to Q over T. So I'm going to use the equation I is equal to Q over T. Because I have a time, right? So between here and here, we've got 2 to 5 seconds. I'm going to ignore the first part because there's no current. So I basically have to do two sets of equations. So I'm going to solve for coulombs. So FYI, if I just rearrange this, I can say Q is equal to I times T. So what I'm going to do is I'm going to call it segment 1. We'll call this segment 1 and this segment 2. For segment 1, you would say this equals to the current, and what was the current? 2.5 times the time. Now, it was there from 2 to 5 seconds, so that's 3 seconds. I will get a number. And I will do the same thing for segment 2 because I'm going to add these two up. And I'm going to find the current here, which was 1.25 in segment 2 from here to here. And I'm going to times that by the total number of seconds. You're starting from 5 and you're going to 10, so that's going to be times 5. And that's going to get to be a number. And your answer will be the sum of these two answers. So that's how you do part A. And then what's the total energy dissipated by the resistor during this time? So question B is asking for energy or work or however you want to define it. Yeah, so I'm trying to find the energy, and I had to do a couple of things. So the first thing I did is I said P equals I squared R, because I knew the resistor was 3.5 ohms. And I had found the current from this answer here. So this answer here is, number 1, if you will. Let's say A, actually, and we'll call this B. So I'm going to say basically A squared times 3.5. And this is segment 1. And for segment 2, I'll do B squared times 3.5. And what that's going to give me is it's going to give me power. Now, I know that's not what it's asking for. You're trying to find the work because our second relationship is that power is equal to energy over time, right? And I know the time, right, for each of these segments. I know that this is from 2 to 5 seconds. That's 3 seconds. So then I would repeat this experiment, basically. I would say if power is equal to energy over time, and I'm trying to find the energy for segment 1, I'm going to just say the power from this answer here, right? We'll call this P1 and P2. I'll say P1 equals E over, it was from what, 2 to 5 seconds, 3 seconds. And then do the same thing for number 2. Power 2 is E over, was it 5 seconds? From 5 to 10, yeah. Over 5. Solve for E1 and E2. They will equal some number. This will equal some number. And then the total energy is the sum of the two answers.